Right now, you are staring into a universe that may not be telling you the full truth. Every map of distant galaxies, every deep space photograph, every model of cosmic structure we have ever created might represent only a curated fragment of what actually exists. The night sky appears open, honest, and expansive, yet behind that illusion could lie layers of concealment so profound that we barely comprehend them. What if some galaxies are intentionally hidden? The question sounds like something a speculative filmmaker would ask, but the more astronomers probe the cosmos, the more anomalies they find. Missing mass where galaxies should be, gravitational distortions with no visible source, cold regions in the cosmic microwave background that defy standard models, and vast stretches of space that appear unnaturally empty. These irregularities invite an unsettling possibility. The universe might contain structures, civilizations, or physical mechanisms capable of obscuring entire galaxies from view. Understanding the magnitude of this concept requires recognizing how limited our view of the universe actually is. We do not see galaxies directly in most cases. We interpret them through faint light stretched across billions of years, through gravitational effects on surrounding matter, through distortions of spacetime itself. If even one of these signals is manipulated, shielded, redirected, or silenced, our entire cosmic map becomes unreliable. Concealment, whether natural or artificial, could easily erase a galaxy from our perception. The immensity of space makes that erasure trivial. A civilization with advanced technology, or even an exotic but natural astrophysical phenomenon, would need only to divert or absorb light in a specific region to hide something larger than anything humans have ever built. In a universe spanning trillions of galaxies, hiding a few might not just be possible, but commonplace. The first hints of this idea emerged not from philosophical speculation, but from a persistent scientific conundrum: the missing satellite problem. Cosmological simulations predict that the Milky Way should be surrounded by hundreds of small satellite galaxies, yet we observe only a fraction of that number. Astronomers initially blamed the discrepancy on observational limitations, assuming faint galaxies were simply too dim to detect. But gravitational lensing studies complicate that explanation. The light from distant sources bends around massive objects, and in several cases researchers have detected lensing patterns that match the gravitational influence of small galaxies, yet no luminous matter appears at their locations. These objects seem to have mass, structure, and gravitational presence, but no detectable light. Labeling them dark matter halos has been the convenient solution, but it does not fully explain their characteristics. Dark matter does not typically form structured, disk-like systems resembling small galaxies. These invisible masses behave as though they are organized, dynamic, and potentially more complex than a random dark matter clump. This possibility becomes even more provocative when combined with the existence of the zone of avoidance, a region obscured by the Milky Way's dust and stars. For decades, astronomers assumed it contained little of interest simply because it was difficult to study. But when radio telescopes finally pierced through the interference, entire galaxy clusters were revealed, massive structures that had remained hidden in plain sight. This discovery was accidental, a product of natural cosmic dust rather than deliberate concealment. Yet it proved that the universe can hide enormous structures without effort. If dust can obscure superclusters, what could far more advanced processes hide? The notion of deliberate concealment arises naturally when considering the Kardashev scale of civilizations. A Type 3 civilization, capable of harnessing energy across an entire galaxy, should emit enormous quantities of waste heat detectable in the infrared spectrum. Yet surveys across millions of galaxies find no such signature. This could mean such civilizations do not exist, but statistical reasoning suggests otherwise. In a universe this vast, filled with ancient stars and countless planets, the probability that humanity is the first or only technological species is infinitesimal. A more troubling alternative is that advanced civilizations learned how to hide their energy output, either to avoid detection or to maintain control over their environment. If they can cloak themselves thermally, visually, and electromagnetically, then hiding an entire galaxy is simply an extension of the same capability. Natural processes also provide evidence that concealment is not purely speculative. Dark galaxies, Galaxies composed almost entirely of dark matter with minimal star formation represent one of the most enigmatic phenomena in astrophysics. These invisible galaxies have mass but no light. If nature can create such a structure without engineering, then the foundation for concealment already exists, ready to be exploited or enhanced by intelligent life. Cosmic dust, gas clouds, and extreme gravitational environments can also cloak galaxies effectively. Light can be absorbed, scattered, or redirected across such distances that even a luminous galaxy can become invisible to observers like us. In some regions, light is stretched to wavelengths our instruments cannot detect. In others, gravitational lensing makes galaxies appear displaced or missing. All of these natural mechanisms could be harnessed or mimicked by an advanced civilization aiming to stay hidden. Gravitational anomalies provide some of the strongest hints that hidden structures might exist. When scientists examine the cosmic microwave background, they find unusually cold regions that cannot be fully explained by known physics. Some of these cold spots correspond to known huge voids, but others appear where gravitational modeling suggests a mass concentration should be. These invisible mass concentrations may represent full galaxy clusters concealed behind physics we do not yet understand, or intentionally hidden through some form of gravitational manipulation. If a civilization could bend spacetime in a controlled way, it could divert light, distort observational data, and mask its presence completely. Dark gaps, strange underdense regions scattered across cosmic maps, deepen the mystery. These regions look like voids, but behave inconsistently with natural void formation. They seem too sharp, too symmetrical, or too isolated to be completely natural. Some appear bordered by gravitational walls without corresponding luminous structure. It is as though something inside the region absorbs light selectively, creating an artificially sparse appearance. Combined with unexplained lensing effects, where invisible yet highly structured masses distort light, the argument for intentional concealment becomes harder to dismiss. The idea becomes even more compelling when we consider how old the universe is. With 13.8 billion years of cosmic history, civilizations could have risen, evolved, expanded, and vanished long before humans existed. Given enough time, any civilization could develop technologies capable of manipulating gravity, dark matter, electromagnetic fields, or quantum vacuum energy. With such control, concealment would be simple. A species might hide its galaxy for defense, privacy, energy management, or reasons beyond our understanding. They might scatter outbound light into undetectable wavelengths or absorb it entirely. They might restructure surrounding dark matter to disguise gravitational profiles. They might even create large-scale false voids, convincing the rest of the universe that the region is empty. If even one Type 3 civilization has done this, then the visible universe becomes only a curated, incomplete sample of a much larger hidden reality. Entire galaxy clusters might be veiled behind engineered darkness. Civilizations might observe one another cautiously from behind cloaking fields, each unwilling to reveal its location. The cosmic web itself might be filled with silent, unseen societies living behind layers of intentional absence. The anomalies we observe today, missing satellites, invisible mass concentrations, unexplained lensing, unexpectedly empty regions, could represent glimpses of structures not meant for us to see. Maybe we have already detected the edges of hidden galaxies without realizing it. Maybe the universe's apparent emptiness is not emptiness at all, but the effect of concealment technologies so advanced that they mimic the behavior of voids. The question is no longer whether concealment is possible, but whether we are ready to acknowledge that the universe may be far more crowded, complex, and intentional than it appears. To understand whether galaxies could be intentionally hidden, we must first confront an uncomfortable truth about our own methods. Everything we know about the universe relies on signals that are fragile, contingent, and astonishingly easy to manipulate. Light can be absorbed, scattered, redirected, or stretched beyond detectability. Gravitational fields can be masked, mimicked, or distorted. Entire structures can exist behind curtains of dust, behind clouds of neutral hydrogen, or behind gravitational lenses that warp the sky into illusions. If the universe itself is capable of hiding things from us accidentally, then the possibility of intentional concealment becomes a natural extension rather than a speculative leap. What we think of as cosmic emptiness might simply be our inability to perceive the truth behind multiple layers of physics and time. Many astronomers once assumed that the universe's dark regions were simply devoid of galaxies, but deeper observations repeatedly overturned that assumption. Some of the most empty patches of the sky, areas long believed to contain nothing, have revealed massive structures once technology improved enough to detect them. One dramatic example is the Vela supercluster, completely unseen until recently due to the Milky Way's dust. When radio surveys finally penetrated that dust, they uncovered one of the largest local structures in the universe. This experience taught scientists that even enormous superclusters can hide right next to us for billions of years without being detected. If natural dust can hide a supercluster, then what might engineered absorption fields hide? The idea that advanced civilizations could hide themselves is not new. Freeman Dyson once suggested that any civilization capable of using most of its star's energy would inevitably radiate vast amounts of waste heat detectable as infrared emissions. Decades later, astronomers have found infrared anomalies in only a handful of galaxies, none of which clearly represent engineered megastructures. Instead of the predicted abundance of Dyson-like signals, we see almost nothing. Either advanced civilizations are astonishingly rare, or they are managing their waste heat in ways we cannot yet imagine. One proposed method involves shifting heat signatures into wavelengths our instruments cannot detect, perhaps by channeling energy into neutrinos, gravitational waves, or exotic particles. If such manipulation is possible, then visible light could also be controlled or suppressed with similar technology. The notion becomes even more intriguing when considering gravitational lensing. When light passes near a massive object, its path bends. Astronomers rely on this effect to detect hidden masses, including dark matter. But gravitational lensing can also act as a camouflage mechanism. A civilization capable of manipulating gravity might distort light around its region to create the illusion of empty space. This would function like a cosmic invisibility cloak, redirecting photons along paths that bypass observers entirely. Some theoretical models suggest that a species mastering spacetime engineering could generate localized curvature, effectively sculpting gravity to hide not just one star system, but entire galactic arms or galactic cores. Natural gravitational lensing already creates illusions that trick even the most sophisticated telescopes. Strong lensing can magnify and duplicate distant galaxies, while weak lensing subtly distorts their shapes. If nature can bend light so dramatically by accident, then an intelligent species with precise control could refine the effect into deliberate concealment, redirecting light into patterns that mimic the absence of anything significant. Imagine a galaxy whose starlight is bent around itself so that observers see only the galaxy's outskirts or nothing at all. Such a structure would appear to astronomers as a void, even if it contained trillions of stars. Another line of evidence for hidden galaxies comes from diffuse radio emissions in regions with no corresponding optical sources. In several surveys, astronomers have discovered vast radio structures with no visible galaxies associated with them. These radio sources behave like remnants of active galactic nuclei or massive star-forming regions, yet the galaxies that should be emitting these signals are invisible in optical and infrared wavelengths. The simplest explanation is dust obscuration or extremely low surface brightness, but those explanations fall apart in cases where the expected infrared signatures are also missing. This suggests that some galaxies emit radiation primarily in wavelengths we do not monitor frequently, or that their visible and infrared emissions are being absorbed or redirected. Deepening the mystery is the phenomenon of ultra-diffuse galaxies, massive galaxies with the brightness of small dwarfs, so faint that they almost disappear against the background sky. Some have the mass of the Milky Way, but only a fraction of its stars, suggesting that star formation was suppressed, or that starlight was somehow diminished. Many of these galaxies exist in clusters, where interactions with hot gas or dark matter can strip stars and gas. But a growing number have been found in isolation, where no environmental process should have dimmed them. A few theories propose that something prevents their starlight from escaping, possibly dense clouds of primordial gas or self-generated radiation absorption. If suppression of visible light can occur naturally, it does not stretch the imagination far to envision an artificial analog. Yet the most unsettling evidence for potential concealment comes from the misalignment between simulations and observations of cosmic structure. Simulations consistently predict more galaxies than we find. The missing galaxies problem extends beyond the Milky Way into multiple regions of the universe. Even after accounting for detection limitations, the shortfall remains. Some astrophysicists propose that dark galaxies, composed mostly of dark matter and containing very few stars, fill the gap. But gravitational modeling in certain regions suggests the masses of these invisible objects are too organized, too clumped, and too gravitationally effective to be mere dark matter halos. They behave like assembled structures, not random clumps. This organized behavior hints at the presence of unseen galaxies, either naturally dark or deliberately veiled. The problem grows deeper when examining the cosmic microwave background. In several areas, gravitational imprints suggest masses where no galaxies appear. These are not small deviations but large-scale anomalies inconsistent with a universe where luminous matter traces mass distribution accurately. Either our understanding of structure formation is flawed, or something is suppressing the luminous signatures of these regions. The suppression may be natural, the result of unusual conditions inhibiting star formation or obscuring radiation, but it could also be artificial, engineered by advanced species seeking to eliminate detectable electromagnetic emissions. Why would a civilization do this? Several motivations emerge from theoretical discussions among astrophysicists and philosophers of extraterrestrial intelligence. The first is defense. In a universe where advanced civilizations may exist, hiding might be safer than broadcasting signals. The second is energy management. If a species can control its galaxy's radiation, it might do so to manage heat flows or to harness energy more efficiently. The third is cultural or philosophical. A civilization might choose isolation, shielding itself from outside contact, or preventing contamination of younger civilizations like ours. The final motivation is one we cannot imagine, because it emerges from forms of intelligence and physics beyond our understanding. But concealment might also be passive rather than active. If civilizations utilize exotic technologies, like harvesting energy from dark matter, threading space-time with artificial wormholes, or enclosing stars in structures that trap radiation, then the byproduct might be inadvertent obscuration. In that case, the hidden galaxies are not hidden out of intention, but because their inhabitants' normal engineering practices shift their electromagnetic signatures out of our detection range. In other words, we might be seeing the universe incorrectly simply because we do not know what to look for. Some researchers argue that the evidence for hidden galaxies is not technological, but cosmological. They propose the existence of mirror matter, a hypothetical counterpart to ordinary matter that interacts primarily through gravity. If mirror stars and mirror galaxies exist, they would be invisible except through their gravitational pull. This would explain lensing anomalies, missing masses, and unexpected gravitational flows. If mirror matter galaxies share the same cosmic space with ordinary galaxies, then our maps are fundamentally incomplete. The universe could contain twice as many galaxies as we believe, with half of them composed of matter undetectable by our senses and instruments. If mirror matter exists, the next question arises: could civilizations in mirror galaxies perceive us? Would we be invisible to them? If so, the universe might contain multiple overlapping civilizations unaware of each other, occupying parallel layers of gravitational reality, but unable to detect each other's electromagnetic emissions. Concealment in this scenario is not a choice, but a property of physics. The galaxies remain hidden, not through intention, but through incompatibility of interaction. Despite these possibilities, perhaps the most compelling hint that galaxies might be intentionally hidden lies in the phenomenon of coordinated emptiness. Several enormous cosmic voids exist, regions spanning hundreds of millions of light years, where galaxies should exist but do not. The largest known voids are so underdense and so smooth that they challenge our understanding of structure formation. Could something have removed or shielded galaxies from these regions? Could voids represent not natural underdensities, but the aftermath of concealment on scales beyond comprehension? The idea seems radical, but radical ideas are often required to explain radical observations. Some astrophysicists have suggested that voids might be caused by exotic physics, dark energy fluctuations, modified gravity, or cosmic fields unknown to us. But if advanced civilizations exist, their actions might also shape the cosmic landscape. A civilization with the ability to move stars, sterilize regions, or redirect matter on vast scales could carve a void into the cosmic web, whether for harvesting energy, creating safe zones, or hiding entire empires. Such a process could produce the voids we observe. Even if such civilizations do not exist now, the voids could be relics of ancient civilizations long gone. A galaxy or cluster hidden in a void might be extinct, its concealment field still operating autonomously. If true, the universe around us is not merely shaped by natural forces, but sculpted by intelligence, lost to time. Hidden galaxies might be tombs of cosmic cultures, their light erased but their gravitational echoes lingering across billions of years. The thought is sobering. Our cosmic neighborhood may contain the remnants of beings who mastered concealment so thoroughly that only the faint footprints of their existence remain. Their galaxies might sit behind walls of engineered silence, unreachable and unseen. Or they might thrive in secrecy, observing us while remaining invisible. If concealment is widespread, then the visible universe is merely a thin, curated veneer atop a far larger, hidden architecture. If some galaxies are intentionally hidden, then one of the most important questions is not how they are concealed, but when. The response a civilization chooses, revealing itself or fading into darkness, depends on cosmic timing. A species living in a young universe filled with turbulent star formation, violent mergers, and intense radiation fields might have radically different motivations from one living in a calm universe billions of years later. To understand hidden galaxies, we must consider the history of cosmic eras and how civilizations might behave differently across them. In the earliest epochs of the universe, during the first few billion years, galaxies were chaotic. They collided frequently, grew rapidly, and produced stars in explosive bursts. Any civilization arising in such conditions would face constant threats: gamma-ray bursts, hypernovae, black hole activity, and gravitational instability. Concealment would have little purpose when survival itself was uncertain. In that environment, civilizations would focus on endurance, not secrecy. The dangers were too frequent, too random, and too powerful. Cosmic violence did not care whether someone was hiding, but the universe aged. It expanded, it cooled, it quieted. Galaxies stabilized, star formation slowed, black hole activity diminished, environments became more predictable. This transition created the first era in which long-term planning was possible on galactic and intergalactic scales. Civilizations could consider choices spanning millions, even billions, of years. And with long-term planning came motives that were not present earlier. Motives like preservation, autonomy, or concealment. Imagine a civilization emerging during the calm Middle Age of the universe, around 6 to 10 billion years after the Big Bang. Their galaxy might have already settled into a stable configuration, with steady star formation and predictable dynamics. Such a civilization might look outward and realize that the universe is vast and filled with unknowns. They might also realize that any species advanced enough to cross intergalactic distances would be difficult to resist. In such a universe, hiding becomes a rational strategy. The Milky Way today sits in this Middle Age era. We arose not in chaos, but in a cosmic period where galaxies had matured enough to allow complex chemistry, stable planets, and long-lived stars. If other civilizations emerged in similar environments, they would have confronted similar realizations. That visibility is a risk. However, an even more intriguing era follows. As dark energy accelerates expansion, galaxies grow more isolated, cosmic distances stretch, interactions become rare. In the far future, hundreds of billions of years from now, civilizations might exist in extreme solitude, separated by expanding voids. Their skies would grow emptier, signals from beyond their local group would fade. In such a universe, concealment becomes effortless because darkness becomes the default. The question is whether some civilizations reach that isolation early through intentional engineering. If a species wanted to accelerate its isolation, it could dim its stars, cloak its galaxy, or redirect light away from observers. With enough energy and technology, it could create artificial darkness around its region, long before the natural expansion of the universe achieved the same result. This raises a profound possibility. Some hidden galaxies might not be hiding from others. They might be hiding from the universe itself. They might be creating artificial isolation, a manufactured loneliness that allows them to control their destiny. Civilizations might pursue isolation for reasons we cannot easily guess. They might fear cosmic predators, entities that move from galaxy to galaxy, preying on energy-rich civilizations. They might avoid interference with younger species. They might engage in vast experiments requiring complete electromagnetic silence. Or they might be withdrawing into deeper layers of physics, transitioning from luminous matter to exotic states of existence invisible to our senses. A galaxy intentionally hidden could be a stepping stone toward a more profound transformation. Suppose an advanced civilization transitions to living inside computational substrates woven into space-time itself. Their galaxy might be quiet, dim, or invisible because they no longer rely on stars or planets. Their engineered habitats could be embedded in compact dark matter structures, quantum fields, or black hole horizons. If so, the luminous galaxy we expect to see might have already faded, replaced by architectures we cannot detect, or that we mistake for dark matter itself. This leads to a compelling hypothesis. Perhaps some hidden galaxies are not hiding at all. Perhaps they have evolved beyond luminosity. They may have shifted their existence into lower energy forms where photons are inefficient. They might store information in neutrino fields or pass consciousness through zero-point energy. If so, hiding is not their intention. It is merely a byproduct of operating in domains where electromagnetic radiation is irrelevant. The idea becomes even more intriguing when we consider that natural dark galaxies already exist. Astronomers have found galaxies almost entirely devoid of stars, composed mostly of dark matter with minimal luminous components. These galaxies are faint, diffuse, and nearly invisible. If nature can produce dark galaxies accidentally, then a civilization that understands the physics of dark matter could produce them on purpose, transforming their luminous galaxy into a dark matter-dominated one. They would become nearly undetectable, leaving only gravitational signatures. But what if even gravitational signatures can be manipulated? Gravity is the fabric of spacetime, and if a civilization can engineer spacetime curvature through exotic energy densities, controlled perturbations, or artificial mass distributions, it could distort gravitational fields to mask its presence. Such a galaxy might appear as a perfectly ordinary dark matter halo, or even as a void. We might be staring at engineered gravity without realizing it. To explore intentional concealment further, we must examine the strange phenomenon of missing baryons. Cosmologists know that around 5% of the universe is normal matter, yet only a fraction of that matter has been found. The rest should exist somewhere, perhaps in hot intergalactic gas, warm plasma, or diffuse filaments. But some researchers believe that part of the missing baryons may be locked away in structures we cannot detect, possibly hidden inside engineered clouds that trap energy, absorb light, or scatter photons away from our telescopes. If so, some of the missing baryons might belong to hidden civilizations. These engineered clouds could be enormous, light years across, absorbing the emissions of entire stellar populations. They would act as cosmic cloaks, shielding a galaxy from observation. Similar behavior occurs naturally in the zone of avoidance, where the Milky Way's dust blocks up to 20% of the extragalactic sky. But engineered dust would be more precise, more controlled, and more effective. It would not leave infrared traces or reveal chemical signatures the way natural dust does. It might be tuned to absorb specific wavelengths while allowing others to pass. It might be composed of exotic particles with interaction properties that evade detection. Another possibility is the manipulation of cosmic background radiation. A hidden galaxy might adjust its emission spectrum to mimic the cosmic microwave background, causing telescopes to mistake its radiation for noise. If a galaxy's emitted photons are thermalized or diffused into a spectrum identical to the background, the galaxy becomes invisible. This requires staggering technological capability, but such capability is exactly what a galaxy-scale civilization would possess. But there is a deeper mystery, one that pushes concealment beyond simple hiding. Some hidden galaxies might not merely be obscured, they might be replaced. Their absence could be intentional removal rather than intentional concealment. If civilizations relocate their stars, dismantle their stellar systems, or consume them for energy, they could erase the luminous structures entirely. This process could leave behind dark matter halos, gravitational remnants, or empty regions that mimic natural voids. In this view, hidden galaxies are not hidden, they are gone. Why would a civilization dismantle a galaxy? One theory suggests that the energy density of stars is inefficient compared to exotic matter or vacuum energy. A civilization might extract stars for fuel, collapsing them into black holes or converting them into exotic energy sources. Over billions of years, the galaxy's light would dim and eventually vanish. Another theory argues that large-scale engineering might require clearing matter from a region to create experimental grounds. A civilization performing controlled physics on cosmic scales might need empty space to isolate variables. Or perhaps civilizations migrate inward, toward the galaxy's central supermassive black hole. If they harness the rotational or accretion energy of the black hole, they might relocate their habitats into regions close to the event horizon, where gravitational time dilation slows time dramatically. To external observers, time near the black hole moves slowly. A civilization living there would appear static or non-evolving. Their energetic emissions would be redshifted beyond detection. If enough civilizations migrate toward their galactic centers, the galaxies themselves might gradually fade. Their stars might be abandoned. Their spiral arms might decay. Their energy consumption might shift inward until the galaxy becomes a near-dark shell. Observers like us would interpret these galaxies as missing, hidden, or ultra-diffuse, when in truth, they have moved inward into domains where light barely escapes. Finally, consider a universe where civilizations systematically hide, because all those who fail to hide are eliminated. This concept, known as the dark forest hypothesis, suggests that intelligent species avoid detection because visibility invites destruction. If this is correct, some galaxies might hide not through vanity or philosophy, but through necessity. They exist in a cosmic environment shaped by predators or unknown dangers. Their concealment is a survival strategy, and their hidden galaxies are sanctuaries. If true, we might be living in a universe that is far more populated than it appears, but one where silence is the rule. The galaxies we cannot see may be thriving, luminous in their internal structures, but invisible from afar. They monitor us quietly, evaluating whether we are safe to contact or too dangerous to reveal themselves to. And perhaps most unsettling, they may be waiting for us to make a mistake. If some galaxies are intentionally hidden, the next question becomes unavoidable. How do we detect something that does not want to be found? The hunt for concealed galaxies demands that we confront a paradox. A hidden galaxy, by definition, avoids our instruments. Yet the universe is interconnected. Gravity penetrates darkness. Motion leaks clues. Light can be bent, scattered, distorted, or delayed. A galaxy trying to hide might succeed at masking its light, but it cannot easily escape the laws of physics. The key is knowing which laws reveal the footprints of the unseen. Astronomers often say that gravity has no shadow. Even the darkest object still curves space-time. And this is where the search begins. When we map the universe, we often find invisible structures through gravitational lensing, the bending of light around massive objects. If a hidden galaxy clusters with others, its gravitational field would distort the light from galaxies behind it. To an experienced cosmologist, such distortions appear like fingerprints pressed into the fabric of space-time. They reveal that something massive, something significant, is there. But what if a civilization knows this? What if it understands that lensing gives away its presence? Concealing gravity itself might seem impossible, yet theoretical physics has proposed ways that exotic matter, or engineered mass distributions, could distort, smooth, or negate gravitational signatures. A galaxy that intentionally manipulates space-time could create misleading gravitational patterns. It could mimic the lensing profile of a void, a mere dark matter halo, or a region of diffuse gas. In that scenario, we might have already detected hidden galaxies, yet misclassified them as something else entirely. Consider ultra-diffuse galaxies. These faint, ghost-like structures populate galaxy clusters and voids, spreading their stars over enormous areas, making them nearly invisible. Some contain little or no dark matter. Others seem to be dominated by it. Their existence contradicts simple galactic evolution models. It is possible that some are natural anomalies, but perhaps some are engineered camouflage. Galaxies deliberately stretched or dispersed to reduce their brightness while maintaining internal functionality for their inhabitants. The strangeness grows deeper when we look at oddly high mass-to-light ratios found in some systems. Certain galactic structures appear far too massive for the amount of light they emit. The usual explanation is dark matter. But if dark matter and artificial concealment produce similar observational signatures, the two could be confused. Hidden galaxies might lurk inside what we assume to be dark matter-dominated halos. More perplexing still are orphan gravitational lenses, lensing events that appear without any visible or infrared object to cause them. These lenses distort background light in predictable ways, yet telescopes detect no corresponding galaxy. Some researchers attribute these events to faint or distant structures beyond current detection limits, but others argue that these lenses may represent a category of objects fundamentally refusing to emit detectable radiation. What if a galaxy has been deliberately stripped of its luminous matter? What if the remaining civilization operates entirely inside a dark matter halo, using engineered environments far more energy efficient than stellar light? This question leads to a second detection strategy: motion. Galaxies interact gravitationally, pulling on each other in predictable ways. A hidden galaxy would still be subject to gravitational attraction and repulsion, influencing the motion of its neighbors. If a region of space shows velocity anomalies, peculiar movements that cannot be explained by visible structures, then something unseen might be responsible. These peculiar velocity fields are already observed in several cosmic regions. They are attributed to massive but invisible structures like dark attractors. Yet dark attractors may not all be natural. Some might be engineered zones of mass concentration, hidden galactic centers masked from light-based instruments, but fully active gravitationally. If civilizations understand mass manipulation, they could control these velocity fields intentionally, disguising themselves behind patterns that appear natural to inexperienced observers. This notion becomes even more compelling when we consider voids. Some voids appear too large, too deep, or too coherent to align with standard cosmological predictions. If hidden galaxies are operating inside voids, they may be manipulating or redistributing mass to maintain their concealment. They could be disguising themselves as emptiness, the ultimate camouflage. After all, hunters rarely search the regions they believe to be empty, but detection strategies extend beyond gravity and motion. Another approach involves analyzing anomalies in cosmic radiation backgrounds. A galaxy that hides its light might still produce waste heat, entropy, or other thermodynamic signatures. Search for unusual infrared backgrounds, small excesses of faint diffuse radiation, and one might find remnants of engineered heat dispersal systems. Some galaxies appear colder than expected, emitting far less radiation than their star content implies. These anomalously cold galaxies could be using advanced cooling technologies, shedding waste heat into invisible channels. Some physicists propose that civilizations could radiate waste heat not as infrared photons, but as neutrinos or gravitational waves. Neutrinos interact so weakly that even enormous fluxes would remain hidden. A galaxy radiating its thermal waste through neutrinos would be undetectable to every telescope humanity possesses today. This raises the unsettling possibility that the universe is full of civilizations whose galaxies run cold, deliberately cooled below natural energy output levels to evade detection. If so, our instruments might be looking for the wrong kind of light. But the most radical detection method concerns something far stranger: the topology of spacetime. If civilizations manipulate spacetime itself through wormholes, engineered curvature, or artificial horizons, the geometry of the universe would contain anomalies. Cosmic topology surveys search for repeating patterns in the cosmic microwave background, looking for signs that the universe is connected in unexpected ways. A civilization altering spacetime around its galaxy might inadvertently leave signatures in these patterns. It might create distortions, discontinuities, or gravitational waves that ripple across the cosmos. Yet detecting such anomalies requires sensitivities far beyond current technology. The signatures might be subtle, buried in noise, or confused with natural inflationary features. A sufficiently advanced civilization could even tune its manipulations to imitate natural cosmic microwave background variations. The ultimate camouflage would align itself with the universe's own primordial patterns. Some researchers propose that the lack of strong cosmological anomalies is itself suspicious. If the universe looks too uniform, too smooth, and too isotropic, perhaps some structures are actively maintaining that uniformity. A hidden civilization, or many, might be blending their presence into the cosmic background, like skilled artists airbrushing imperfections into an image. But the search for concealed galaxies becomes even more challenging when we consider that some may be hidden by design only temporarily. A civilization might toggle its visibility, revealing itself under specific cosmic conditions or to specific observers. It might use signaling protocols encoded in gravitational waves, neutrinos, or dimensional fluctuations. We would never detect such messages unless we knew what to look for. Imagine a galaxy that appears normal, shining like any other. Then without warning, it dims, shifts spectrum, or disappears entirely. A natural explanation might be dust, distance, or observational error. But what if the galaxy is communicating, testing, or protecting itself? What if galaxies vanish because they choose to? There are already examples in astrophysics where galaxies seem to dim unpredictably. Some cosmic structures fade in ways inconsistent with normal stellar population decline. Some galaxies show abrupt drops in infrared output or sudden changes in rotation curves. These are typically attributed to observational artifacts or interactions with intergalactic gas, but the patterns do not always fit neatly into standard models. What if these are concealment phases? Galaxies shifting between luminous and hidden modes, depending on internal needs or external threats. This brings us to the most difficult detection problem: intentional misdirection. A hidden civilization might not merely conceal itself, but actively manipulate what we observe. It might generate false signals, mimic the spectra of distant stars, or create artificial galaxies to distract from its true location. Entire regions of space could be illusionary. Projections crafted through exotic physics. Light could be redirected through engineered gravitational lenses to create phantom structures. In this scenario, the night sky becomes a stage. Some galaxies may be real. Others may be projections. Some voids may be empty. Others may be filled with hidden civilizations watching silently from behind engineered darkness. If this seems implausible, consider that even humanity has begun experimenting with directed energy, cloaking technologies, and signal manipulation. Our earliest steps hint that advanced civilizations could manipulate electromagnetic fields, gravitational curvature, and quantum states with ease. On cosmic scales, these manipulations become indistinguishable from natural astrophysical processes. Yet there is one final detection method, a method that no civilization, no matter how advanced, may ever fully defeat: entropy. Every action increases entropy. Every machine, every structure, every life form produces waste, heat, or inefficiencies. A hidden galaxy might mask its light, distort its gravity, and suppress its radiation, but it cannot escape entropy. If we learn to detect subtle entropy signatures, microscopic disturbances in vacuum energy, slight shifts in cosmic neutrino backgrounds, or exotic particle fluxes, we might uncover civilizations that believe themselves perfectly hidden. Entropy does not lie. It cannot be camouflaged easily. It betrays every attempt at perfection. It reveals everything that tries too hard to remain unseen. If humanity learns to read entropy patterns the way we read light, we may one day find that the universe is far more crowded than it appears, and that we have been surrounded all along by galaxies that thought themselves invisible. If some galaxies are intentionally hidden, then the question of motivation becomes unavoidable. Concealment on a galactic scale is not a trivial choice. It is an act of immense coordination, requiring mastery of physics, energy, and time, far beyond what humanity can achieve. A civilization capable of hiding an entire galaxy must operate on principles so advanced that their view of reality likely differs from ours at a fundamental level. Understanding why such a civilization might choose isolation demands that we confront not only astrophysics, but psychology, game theory, survival logic, and the long-term consequences of cosmic evolution. The simplest explanation is self-preservation. In a universe where visibility can be dangerous, hiding becomes a rational strategy. The dark forest hypothesis describes a universe filled with civilizations, each wary of revealing itself. Any species that broadcasts its existence risks annihilation by another species that assumes a preemptive strike is the safest course. In such a universe, silence becomes the only universal language. Concealed galaxies would be the natural extension of this idea, a survival strategy scaled up to cosmic proportions. But the dark forest model presupposes a universe filled with predators. It assumes that the most advanced civilizations behave aggressively, consuming resources or eliminating competitors across galactic distances. Whether such predators exist is unknown. But if even one hostile species operates at intergalactic scale, then every other civilization must behave cautiously or risk extinction. The safest response is to remain hidden behind engineered cosmic shadows. However, predation is not the only possible motive. Some civilizations might conceal themselves not out of fear, but out of respect. Perhaps they observe younger civilizations without interfering, avoiding detection to prevent contamination. If cosmic ethics exist, rules about minimizing influence on less developed species, then invisibility would be a moral choice. They hide so that emerging civilizations can develop independently. A hidden galaxy could be a sanctuary of watchers or archivists, observing the universe's unfolding without leaving traces. Another possibility emerges when considering cosmic-scale experimentation. A civilization might hide its galaxy to perform physics beyond the standard model. Experiments involving vacuum energy, dark matter manipulation, or engineered spacetime. Such activities could produce signatures dangerous or disruptive to other regions. Concealment would prevent contamination, interference, or detection of hazardous side effects. A galaxy engaged in controlled manipulation of fundamental forces might be indistinguishable from a void. Just as laboratories on Earth are contained and shielded, a hidden galaxy might be a cosmic laboratory. A different motive involves resource security. If a civilization has mastered the conversion of matter into usable energy, it might harvest stars, redirect stellar winds, or restructure mass distributions on galactic scales. These processes might require hiding the galaxy to avoid being targeted or interrupted during resource extraction. A hidden galaxy might be undergoing transformation, dismantling stars, converting baryonic matter into exotic forms, or building immense megastructures that reshape its structure. Concealment would prevent others from exploiting or interfering with these resources. Yet there is a possibility, even stranger. Civilizations might hide because they are ashamed. Imagine a civilization that has exhausted its resources, ravaged its environment, or survived catastrophic internal conflict. It might choose to isolate itself, concealing its galaxy from external observers to avoid judgment, contact, or exploitation. A galaxy might hide because its inhabitants no longer wish to participate in cosmic society. Concealment becomes a way to recover, rebuild, or retreat into solitude. There is also the matter of hierarchy. Some civilizations might hide, not from danger, but from more advanced civilizations that exist on higher planes of physics. These higher-level beings might possess capabilities so vast that even detectable luminosity becomes a liability. To avoid unwanted attention or oversight, a galaxy might choose to dim itself, reducing its signature to avoid standing out. This is not fear, but humility, an awareness that the cosmic landscape may contain entities operating on scales far beyond their comprehension. This brings up the possibility of cosmic governance. Perhaps advanced civilizations have formed alliances, agreements, or laws governing intergalactic behavior. One rule might involve concealment. When a civilization reaches a certain level of technological maturity, it must hide itself to prevent destabilizing interactions. Hidden galaxies could be members of a cosmic federation, obeying protocols designed to maintain long-term peace. Their concealment would not be self-imposed, but required by intergalactic law. Alternatively, hidden galaxies might serve as quarantine zones, regions where diseases, artificial intelligence, or uncontrolled technologies have spread. Concealment could be a containment strategy to prevent these threats from spreading to other galaxies. But the most profound motivations might be philosophical. A civilization might hide because it has concluded that visibility is meaningless. Once a species masters matter, time, and energy, it may no longer require physical interaction with the universe. It might view existence itself as an internal process, no longer tied to observable light or motion. A hidden galaxy could belong to a civilization that has retreated inward into digital existence, simulated universes, or quantum substrates. Their physical galaxy might operate on autopilot, powered down and maintained only as a substrate for post-biological consciousness. These civilizations would not care about being seen. Their concealment might be an accidental byproduct of existential transformation, yet the motivations could be darker still. A galaxy might hide because it is enslaved. Imagine a civilization conquered by a more advanced species that forces them into darkness. Their stars are dimmed, their emissions suppressed, and their communication blocked. The galaxy becomes a prison, contained within engineered silence. A hidden galaxy might represent not sophistication, but captivity. Another theory suggests that galaxies could hide to protect themselves from natural cosmic phenomena. Some areas of the universe might contain deadly processes, gamma-ray bursts, hyperactive quasars, exotic radiation fields, or cosmological phase transitions. A civilization might cloak its galaxy to protect it from observational bias or exposure to unknown cosmic hazards. Their concealment might serve as a form of shielding, preventing disruptive interactions with dangerous cosmic forces. But perhaps the most chilling motivation is this: some galaxies might be hiding because they are hunting. A civilization using stealth might wait for other civilizations to reveal themselves. Concealment becomes predatory, not protective. A hidden galaxy could be an ambush predator on a cosmic scale. They monitor the universe silently, searching for signs of activity, waiting for civilizations to broadcast signals or emit detectable artifacts. Once detected, these civilizations might be targeted for assimilation, conquest, or consumption of resources. If hunting civilizations exist, then concealment is not simply wise, it is mandatory. Yet not all motivations imply hostility. Concealment could be a matter of aesthetics. An advanced species might view bright galaxies as wasteful, adopting a minimalist cosmic ideology that favors darkness and silence. They might dim their stars to achieve harmony, balance, or elegance on cosmic scales. Their dark galaxy could be a form of art or expression, representing a philosophy that embraces subtlety over spectacle. Some civilizations might hide to meditate on cosmic truths. Their galaxy becomes a sanctuary, free from distraction or interference. Concealment in this sense is spiritual, not strategic. Another motive arises when considering time. Civilizations might hide because they exist on timescales far different from ours. They might operate so slowly that visible interaction with the universe becomes irrelevant. A galaxy that appears frozen or dim might simply be functioning on time frames millions of times slower than ours. Their concealment is not deliberate, but a side effect of how they operate. Alternatively, civilizations might hide because they are waiting for cosmic cycles to shift, waiting for dark energy to evolve, waiting for the universe to cool, waiting for a predicted cosmic event, waiting for the next phase of universal evolution. Their concealment might be a temporary state, one leading to a future transformation. Some civilizations might hide because they have discovered something terrifying, that the universe itself is watching. If consciousness or awareness emerges from cosmological processes, a civilization might hide from the universe's own gaze. Their concealment becomes metaphysical, a defense against a cosmic observer embedded in the fabric of reality. And then, there are civilizations that hide without any strategic reason. They hide because they can, because it is possible, because consciousness, like nature, often seeks novelty. A galaxy might hide simply as an aesthetic act or a form of cosmic play. Concealment could be a performance, a challenge, or a message to other advanced civilizations. In the end, the motivations for hiding a galaxy might be as diverse as the motivations for anything else in the universe. Some may hide from fear, others from wisdom, others from curiosity, and others from madness. The universe is large enough for all of these possibilities, and for many more we cannot yet imagine. If some galaxies are intentionally hidden, then we must also confront an unsettling possibility. What if concealment is not an exception in the universe, but the rule? Earth's night sky might not represent a typical cosmic environment. It might be the filtered version, the quiet outskirts of a universe that, in reality, is filled with intelligent life, shrouded behind vast curtains of engineered darkness. To explore this, we must examine a deeper layer of cosmology, the concept that the visible universe is only the exposed surface of a much larger, largely invisible, civilization-filled cosmic ecosystem. The first clue emerges when we consider the cosmic silence known as the Fermi paradox. The paradox is simple. The universe is vast, old, and full of planets. Intelligent life should be common, but we detect nothing. No signals, no megastructures, no shadows of massive technological activity. This silence is often taken as evidence that intelligent life is rare. But what if silence is simply evidence of successful concealment? In a universe where hiding is essential, civilizations that reveal themselves vanish, leaving only the quiet ones to persist. The universe we observe, then, is shaped not by what exists, but by what survives. Hidden galaxies could represent the cosmic majority, civilizations that learned early that being visible is an existential risk. Their silence defines the cosmic landscape more powerfully than their existence. Yet if concealment is the rule rather than the exception, the next layer of inquiry is even more profound. If most advanced civilizations hide, then the universe's visible galaxies, bright, exposed, and radiating, might be the cosmic equivalent of children, young civilizations, primitive systems, or unclaimed galaxies that have not yet learned the dangers of exposure. The galaxies we can see might be the least advanced or least aware. The true centers of galactic intelligence could lie behind veils of engineered invisibility, hidden so deeply in dark matter or exotic physics that humanity has no instrument capable of detecting them. This leads to the unsettling conclusion that the universe we observe is the training ground, while the real cosmic society resides in shadows. Some scientists have proposed that the observable universe is biased toward detecting low-complexity systems. In physics, this is known as selection bias. We see what is easiest to see, not what is representative. Hidden galaxies might represent extremely high-complexity structures that choose not to emit detectable radiation. Their concealment may be so effective that we misinterpret them as empty space, cold voids, or dark matter. In fact, some dark matter halos could be misidentified megastructures, starlight-shielded civilizations operating inside ultramassive engineered shells. If a civilization constructs a Dyson shell-scaled structure around an entire galaxy, the result would be indistinguishable from a dark matter halo. Gravity would remain, but light would vanish. Some spherical, anomalous mass distributions observed in galaxy clusters have no luminous components at all. They are explained as dark matter conglomerations. But what if some are constructs, intentionally built to hide hundreds of billions of stars? This raises an even deeper possibility. Perhaps dark matter itself is not entirely natural. Perhaps some fraction of it consists of engineered matter created by civilizations to cloak themselves, camouflage their movements, or reshape cosmic structure. Exotic matter with negative pressure, negative mass, or phantom behavior could be technologically synthesized. If so, the cosmic web itself might have been partially influenced by the actions of ancient, hidden civilizations. Such a concept suggests a universe far more populated than our observations imply. To investigate this, we must examine the distribution of dark matter. Dark matter is not uniform. It clusters into halos around galaxies and filaments across cosmic voids. But certain regions show strange abnormalities. Halos without galaxies, filaments with no luminous matter, and voids deeper than expected. These anomalies could all be explained in natural terms, but they could also represent the footprint of concealed civilizations on cosmic scales. Consider dark galaxies, galaxies with few or no stars. Some appear as rotating gas clouds held together by unseen mass. Others show rotation curves indicating internal gravitational structure, but no visible stars. These systems are often described as failed galaxies. But what if they are successful concealment attempts? A galaxy that has intentionally extinguished or hidden its stars might appear identical to a dark galaxy. Only gravitational traces reveal its presence. Some of these halos might contain trillions of individuals living in artificial environments, powered not by stars, but by energy extracted from vacuum fluctuations, black hole spin, or quantum fields. These galaxies would be invisible by design. We should also consider the age of cosmic structures. Some galaxies formed exceptionally early, too early for standard cosmological models to fully explain. Some existed only 300 million years after the Big Bang, far sooner than models predicted. These early giants could be natural, or they could be the remnants of civilizations that existed before star formation stabilized. If those ancient civilizations survived, adapted, and evolved, they might have mastered concealment billions of years before the Milky Way formed. Such civilizations would have had immense amounts of time to refine their concealment technologies. They would appear indistinguishable from natural cosmic structures, unless we learn to detect the subtle signatures of artificiality. The next layer of analysis involves cosmic background radiation. Advanced civilizations could manipulate the local cosmic microwave background, using it as a mask. By adjusting their heat emissions to match the local background temperature, they could blend into cosmological noise. Some anomalies in the cosmic microwave background show temperature dips that align with massive voids. These dips are typically explained by the integrated Sachs-Wolf effect. But if an engineered structure absorbs or redirects CMB radiation, the effect would be similar. Hidden galaxies might be using the universe's own oldest radiation as camouflage. Another key clue lies in missing baryons. Cosmologists have noted that only about half of the baryonic matter predicted by Big Bang nucleosynthesis has been detected. The rest remains missing. One explanation is that this matter exists in faint, diffuse filaments. Another is that it resides in hot intergalactic plasma. But a more exotic interpretation is that some of the missing baryons have been captured, transformed, or hidden by advanced civilizations. If civilizations absorb baryons to create exotic matter, conceal stars, or power vast technologies, their galaxies would grow dimmer, eventually disappearing from visible wavelengths. An even more startling possibility is that some hidden galaxies might not be located where we think galaxies should be. They might not follow the standard cosmic web structure. If a civilization can manipulate gravity, they could remove themselves from local gravitational flows. They could drift off the cosmic filaments, isolate themselves in engineered spacetime pockets, or surround their galaxy with repulsive mass distributions, creating their own gravitational wells or anti-wells. Astrophysicists have detected areas where galaxies appear to be missing, but gravitational flows indicate mass concentrations. These dark attractors behave unpredictably. While natural explanations exist, some could be artificial gravitational structures designed to redirect or mask entire galaxies. This possibility becomes even more compelling when we examine strange large-scale flows, coherent motions of galaxies over hundreds of millions of light years. Some flows appear too large to be generated by known mass concentrations. If hidden galaxies or hidden superclusters exist, their gravitational influence might explain these flows. A population of stealth galaxies could be shaping cosmic motion patterns while remaining entirely invisible. Another relevant concept is cosmic engineering aimed at long-term survival. A civilization might hide its galaxy to preserve resources for the far future. As the universe expands and cools, energy becomes increasingly scarce. Stars fade, galaxies drift apart. A civilization preparing for this inevitable energy scarcity might reduce luminosity to conserve energy, dismantle stars to store matter, or convert photons into lower energy states that are easier to trap and reuse. In doing so, they would fade from observational visibility. We see examples of galaxies whose stellar populations appear oddly old, whose stars die faster than new ones form, and whose light output is suspiciously low. These galaxies might be natural, but they could also be in conservation mode, civilizations preparing for the deep future by minimizing waste. A civilization prioritizing long-term stability might prefer darkness to luminosity. Another possibility is that hidden galaxies are not only concealed but interconnected. Civilizations might link their galaxies with artificial wormholes, forming an intergalactic network invisible to external observers. Each hidden galaxy becomes a node in a larger structure. These wormhole networks would not emit light and would not be detectable except through subtle modifications in space-time curvature. If humanity discovered micro-anomalies in gravitational wave patterns or unexplained space-time geometries, these could indicate the presence of wormhole-linked hidden civilizations. Finally, we must consider the most disturbing possibility of all, that hidden galaxies might be actively observing the visible universe, including us. They might monitor young civilizations, mapping their development, waiting for them to reach a certain level of technological maturity. Their concealment would prevent young species from panicking, imitating them, or reacting unpredictably. In this scenario, the universe is not silent, it is supervised. Humanity might be living inside a cosmic nature reserve maintained by galaxy-scale stewards who watch from behind engineered shadows. If this is true, then when humanity eventually masters energy, light, and gravity, we might discover that the darkness around us is not empty at all, but full of ancient observers waiting for us to open our eyes. If some galaxies are intentionally hidden, we must confront a question far more unsettling than concealment itself. How would we ever detect their presence? The problem is not merely technological, it is philosophical, observational, and epistemological. Hidden galaxies challenge the foundations of how humans define reality through light. Our entire cosmic understanding rests on photons, gravitational signals, neutrinos, and the faint imprints of ancient radiation. But what if the most advanced civilizations operate entirely beyond these channels? What if they have withdrawn from the observable universe into domains where human instruments cannot reach, not because our tools are primitive, but because these civilizations deliberately avoid using physics that creates detectable signatures? This possibility requires us to rethink the difference between visibility and existence. Humanity assumes that if something exists, it must produce detectable effects. This is not necessarily true. A civilization could manipulate energy in ways that do not produce electromagnetic leakage. It could operate with perfect thermodynamic efficiency. It could compress spacetime around its structures to redirect emissions. It could even exist within engineered vacuum states that cancel out thermal or gravitational disturbances. Such a civilization would not merely be hidden, it would be undetectable in principle unless we knew exactly what to look for. When considering how some galaxies could be intentionally concealed, we must examine 4 categories of concealment: structural, energetic, gravitational, and dimensional. Each operates at different scales, but all are theoretically achievable for a civilization millions or billions of years older than humanity. Structural concealment involves physical barriers built around stars, clusters, or entire galaxies. These barriers could be megastructures composed of ultra-dark materials, metamaterials that bend light around them, or even active cloaking systems that modulate radiation to mimic empty space. The construction of such massive structures requires energy beyond anything humans can imagine, but not beyond what a Type 3 civilization could accomplish. If such civilizations exist, they may have built shells around their galaxies to regulate internal starlight, capture radiation for energy, or simply hide themselves. Energetic concealment is even more complex. Instead of building physical barriers, a civilization could suppress or transform light at the source. They could alter the fusion cycles of stars, redirect photons into exotic fields, or convert radiation into gravitational waves. A galaxy full of such stars would appear dark, cold, and indistinguishable from a dark matter halo. If this process is efficient, the civilization can maintain energy while remaining invisible. This version of concealment would leave almost no electromagnetic trace. Only subtle anomalies in gravitational dynamics would reveal the presence of a hidden mass concentration. Gravitational concealment is perhaps the most ingenious possibility. Instead of hiding light, a civilization could hide its gravitational footprint. Gravity, in human understanding, cannot be shielded or blocked, but advanced manipulation of space-time curvature could redirect gravitational waves, alter geodesic structure, or create synthetic negative mass regions to cancel gravitational signatures. An entire galaxy could effectively flatten its presence, reducing its gravitational influence on surrounding space. To external observers, the region would appear emptier than it truly is. Such an achievement would imply a level of mastery over general relativity far beyond human capability, but not theoretically impossible. Dimensional concealment is the most extreme. A civilization could shift its galaxy into a different vacuum state, fold it into higher dimensional space, or create an internal bubble universe. Humans might interpret these galaxies as voids, gravitational anomalies, or dark matter concentrations. In this scenario, hidden galaxies are not merely dark, they are displaced from ordinary space-time. Their gravitational influence might leak back in subtle ways, but their light would be entirely absent. Each of these concealment types can solve multiple cosmic mysteries simultaneously. One such mystery involves missing galaxies. Observations predict more small galaxies than are detected. Simulations of dark matter Halos suggest that thousands of dwarf galaxies should orbit large galaxies like the Milky Way, yet many are missing. Concealment provides an explanation. Some dwarf galaxies may be intentionally hidden, transformed by ancient civilizations, seeking stability or isolation. Their faint signatures could be masked behind engineered darkness. Another mystery lies in dark matter itself. Scientists have long speculated that dark matter might be composed of exotic particles, modifications to gravity, or relics of early cosmic physics. But what if dark matter in some regions is artificial? If civilizations manipulate mass energy distribution, the result could mimic dark matter halos. The uniformity of dark matter could itself be a sign of large-scale engineering. An advanced civilization might reshape the galactic halo to stabilize stellar motions or regulate energy flow. Next, consider cosmic voids, vast regions of space containing almost no galaxies. Some voids are so large and empty that their existence strains cosmological models. But if hidden galaxies lie inside them, the voids might not be void at all. Instead, they could be regions where civilizations have cloaked their galaxies to avoid detection by young emerging species. Humanity may mistakenly interpret these regions as barren when they are in fact populated. Even more provocative is the observation that certain galaxies appear to be too perfect. Some galaxies have unusually smooth rotation curves, undisturbed morphology, or improbable symmetry. This could be evidence of long-term engineering. A civilization shaping its galaxy for optimal stability might remove disruptive neighbors, adjust star formation rates, or eliminate rogue structures. A hidden galaxy would need to maintain internal order, and that order could create unnatural smoothness, detectable only through rotation patterns. When it comes to large-scale cosmological surveys, hidden galaxies may also explain discrepancies in Hubble constant measurements, baryon distributions, or bulk flows. If hidden mass concentrations exist, they would modify gravitational fields, influencing galactic motion in ways not accounted for by visible matter. These anomalies appear in surveys as unexplained accelerations, large-scale coherent flows, or density deficits. The presence of hidden galaxies could reconcile these observations without requiring exotic new physics. This raises a critical question. If hidden galaxies influence cosmic structures, could they be communicating with each other? If so, their communications would be invisible to humanity. They might use gravitational waves, neutrino beams, or vacuum fluctuations as signals, channels humans cannot yet detect or interpret. A network of hidden galaxies exchanging information would leave little imprint on the observable universe. Their presence would be concealed not only by technology, but also by the limits of human sensory frameworks. The next challenge is determining how humanity might eventually detect hidden galaxies. One method involves gravimetric mapping, detecting subtle anomalies in the gravitational fields across cosmic scales. If a region shows gravitational influence inconsistent with visible matter, it may hide a concealed structure. However, this method requires extremely precise measurements, far beyond current capability. Another method involves neutrino detection. Neutrinos penetrate almost everything, and certain artificial processes might produce detectable neutrino signatures. A hidden galaxy could have an unusual neutrino background if its energy processes differ from natural fusion. But detecting such a faint signature across billions of light years is nearly impossible. A third method involves gravitational wave mapping. Advanced civilizations might use gravitational waves for communication or energy transfer. Analyzing background gravitational waves could reveal patterns inconsistent with natural astrophysical events. But gravitational wave astronomy is still young. A fourth possibility lies in quantum vacuum distortions. If a hidden galaxy manipulates vacuum energy, or space-time curvature, the surrounding vacuum might have detectable anisotropies. Such distortions could subtly shift light from background galaxies. But distinguishing these shifts from lensing effects is extremely difficult. The most speculative method involves detecting information patterns within cosmic background radiation. If hidden civilizations manipulate the CMB or embed signals within its structure, there could be detectable anomalies. But interpreting these require deep theoretical understanding and sophisticated pattern analysis. Even if humanity detects signs of hidden galaxies, interpreting them would be nearly impossible. Without understanding the technology or physics behind concealment, humans could misinterpret artificial signals as natural anomalies. Indeed, this may already be happening. cosmic microwave background, cold spots, unexplained lensing anomalies, unusual galaxy cluster motions, all may be signatures of concealed civilizations. Yet cosmology assumes natural explanations, because artificiality is untestable with current methods. If some galaxies are intentionally hidden, humanity may be surrounded by civilizations far older, far more advanced, and far more cautious than itself. We may be living in a universe where light is not a guide, but a distraction. The real cosmic map may lie beneath the visible layer, encoded in gravitational patterns, vacuum states, and hidden structures. In such a universe, humanity's observational limitations are not merely technological, they are developmental. Young civilizations see only the surface. Older civilizations dwell beneath it. If hidden galaxies exist, they redefine not only astrophysics, but humanity's place in the cosmos. We become observers of the visible universe, but not participants in the true cosmic society. The universe becomes a layered structure, with young species confined to the outermost layer until they prove themselves capable of seeing deeper. Perhaps the greatest revelation is not that galaxies could be intentionally hidden, but that the visible universe might be the least advanced, least informed region of a much larger reality. And we, unknowingly, may be living inside the universe's faintest layer, the one left visible for beginners. If some galaxies are intentionally hidden, then humanity faces the possibility that the visible universe is not a complete map of cosmic reality, but merely the exposed surface of a deeper, layered structure. And in this final exploration, the question shifts from how hidden galaxies might exist to what their existence implies for humanity's own future. A universe where concealment is common is a universe where danger, wisdom, intelligence, or cosmic etiquette may drive civilizations to erase themselves from view. The motivations behind such concealment may hold more meaning than the act itself. Understanding intention means confronting the possibility that humanity is witnessing not a rare anomaly, but a universal pattern, one that echoes across billions of years and billions of civilizations. The first implication of intentional concealment is that the cosmic silence humanity observes might be artificial. The universe appears quiet because the advanced civilizations within it take extreme measures to remain undetected. This redefines the Fermi paradox from a question of absence to a question of avoidance. Instead of asking, "Where is everybody?" the appropriate question becomes, "Why does nobody want to be seen?" If concealment is widespread, then humanity is surrounded by cultures that have survived long enough to learn that remaining visible carries existential risks. The cosmos may be quiet, not because it is empty, but because it is full, and full of species with long-term survival strategies. Such a universe suggests that advanced civilizations have experienced threats, cosmic, biological, artificial, or intercivilizational, that incentivize invisibility. These threats could include aggressive species that prey on civilizations revealed by their electromagnetic leakage, or autonomous self-replicating machines that follow radio emissions like predators tracking scent. Perhaps in the distant past, early civilizations broadcast boldly, unaware of the consequences. If any of them were exterminated, survivors would have learned. It would only take one catastrophic encounter to convince millions of civilizations that silence is safety, and concealment is the only path to longevity. But the threat need not be external. Concealment could be an internal choice, a philosophical or cultural evolution. Perhaps advanced civilizations recognize that true mastery of space requires letting emerging civilizations grow undisturbed. They might hide themselves to avoid influencing less developed societies, maintaining a cosmic equivalent of non-interference. Their concealment would be ethical, not defensive. They hide not to protect themselves, but to protect the galaxy from becoming a hierarchical environment where ancient powers overshadow younger ones. Their survival, in this case, depends on maintaining balance, peace, and unpredictability in the galactic ecosystem. If concealment is motivated by curiosity, civilizations might hide to study younger species without being detected, observing evolutionary, cultural, or technological paths. Hidden galaxies could be enormous archives filled with observatories, watchers, or historians who track cosmic development without intervention. These civilizations might consider visibility a contamination risk, similar to how humans avoid interfering with pristine ecosystems on Earth. They could view young species as invaluable natural experiments, whose behavior changes the moment they sense observation. Concealment becomes a scientific tool. Other civilizations may hide because they aim to transcend physical constraints. They might occupy engineered habitats with perfect thermodynamic efficiency, avoiding waste heat to maximize longevity. They could manipulate vacuum states, break symmetry conditions, or operate in multi-dimensional space where light is unnecessary. Their concealment is not directed at others, but is simply a consequence of their optimized existence. Their invisibility is an artifact of their advancement, not an intentional strategy. Hidden galaxies then represent not fear or secrecy, but maturity, a stage where life integrates with cosmic physics so thoroughly that it no longer resembles anything familiar. In this context, humanity's visible civilization becomes a beacon of youth. Our emissions, signals, satellites, and megawatt waste heat patterns identify us as newcomers still learning the rules. If hidden civilizations exist, they likely know exactly where we are, how fast we are advancing, and how noisy we appear. They may classify humanity as a civilization transitioning from cosmic infancy to adolescence. In their eyes, our radio leakage is not a threat or curiosity. It is a phase every young civilization outgrows once it understands the consequences of being visible. But what if hidden civilizations enforce silence? Suppose they regulate cosmic behavior through subtle interventions, discouraging young species from revealing themselves too loudly. They might nudge planets, manipulate stellar environments, or cause unexplained failures in early attempts at interstellar broadcasting. These interventions could be invisible, blending into natural astrophysical processes. Stars flicker, spacecraft malfunction, signals distort in ways attributed to solar storms or background radiation. But behind these errors lies intentional suppression, a quiet reminder to remain hidden until humanity understands the risks. A universe with enforcers is a universe where concealment is not optional. That possibility forces a deeper question. If concealment is enforced, who enforces it? It would require a civilization with capabilities far beyond galactic scale, perhaps a multi-galaxy organization, or a civilization millions of years older than any visible structure. Such an entity would be indistinguishable from natural laws. Its interventions might appear as constants, anomalies, or universal principles. We might already be observing its work in unexplained astrophysical phenomena. Dark energy, vacuum instability, or the distribution of matter could reflect not natural processes, but engineered constraints designed to ensure cosmic stability. If hidden galaxies exist as part of a larger network governed by such an entity, the visible universe becomes a training ground, a protected zone for emerging life. Humanity is placed in a region where danger is minimized and interference is forbidden. Only once a civilization reaches a certain level of understanding is it granted access to deeper cosmic layers. This concept mirrors how humans cultivate protected reserves for endangered species, or preserve wildlife by restricting human contact. The cosmos becomes a conservation environment for intelligence, yet concealment may not always be benevolent. A civilization might hide not to protect others, but to protect its own power. Hidden galaxies could be fortresses, cosmic strongholds storing energy, information, or weaponry. Their invisibility ensures strategic advantage. They may monitor visible civilizations to assess threats or stockpile resources for conflicts that unfold on timescales far beyond human comprehension. These conflicts could occur through gravitational manipulation, quantum tunneling, or vacuum perturbations rather than conventional warfare. Hidden galaxies would be the staging grounds for battles fought entirely outside electromagnetic space. Another motivation could be aesthetic or philosophical. Civilizations could hide because they find beauty in isolation. The visible universe becomes a sanctuary for those who choose silence over expansion, contemplation over conquest. These civilizations might build environments within their hidden galaxies dedicated to art, meditation, or exploration of consciousness. Their invisibility is not strategic, it is a cultural expression. To them, being hidden is a choice of identity, a rejection of cosmic noise. If hidden galaxies exist with diverse motivations, defensive, ethical, scientific, philosophical, or strategic, the cosmic landscape becomes a mosaic of intentions layered beneath observable space. Humanity, unaware of these layers, continues building telescopes, mapping voids, analyzing anomalies, and interpreting the universe as incomplete rather than concealed. Such a misunderstanding is inevitable. Without knowledge of concealment, cosmology builds models based solely on the observable universe. Hidden galaxies distort these models in ways interpreted as dark matter, errors, or statistical anomalies. The universe becomes a puzzle missing entire pieces, forcing humanity to build theories that compensate for invisible mass, invisible energy, and invisible structure. The final question humanity faces is perhaps the most unsettling. If hidden galaxies exist, should humanity attempt to reveal them? The answer depends on whether discovery is safe. Revealing a hidden civilization might provoke unintended consequences. If they remain hidden for defensive reasons, discovery could trigger retaliation or even elimination. Humanity's curiosity could become its greatest liability. On the other hand, if these civilizations hide for preservation or observation, they may welcome the moment a young species becomes capable of recognizing them without fear. Detecting a hidden galaxy might be humanity's initiation into a larger cosmic community, but the method of detection matters. If humanity discovers hidden galaxies by accident through gravitational anomalies or cosmic background distortions, hidden civilizations may interpret detection differently than if humanity actively searches for them. Intentional probing could be seen as aggression. Accidental discovery might be seen as maturation. The distinction between curiosity and intrusion becomes essential. A cautious strategy suggests studying cosmic anomalies without attempting to pierce concealment directly. Humanity must observe without targeting, analyze without signaling, and interpret without assuming superiority. If humanity eventually reaches a point where it can build cloaking systems, gravitational manipulators, or quantum vacuum shields, it will face its own version of the choice hidden civilizations once confronted. Should we choose visibility or concealment? If survival favors invisibility, humanity might join the majority by hiding its star systems, cloaking its megastructures, and erasing its emission footprint. If discovery offers connection, humanity might remain visible, risking exposure for the chance of community. Perhaps every civilization at the edge of cosmic adulthood confronts this decision. Perhaps the presence of hidden galaxies reflects the collective answer chosen by most: concealment. And perhaps the visible universe represents the minority, the beginners, the naive, the unguarded. If humanity is among them, then its path forward requires caution and humility. The cosmos may not be a neutral landscape. It may be a silent forest where only the unseen survive. In such a universe, hidden galaxies are not mysteries. They are warnings. Yet the existence of hidden galaxies can also be inspiring. It suggests the universe is richer, deeper, and more complex than even the most ambitious scientific models. It implies that intelligence persists across immense scales, that civilizations endure long enough to transform galaxies, and that life has a future beyond the visible stars. Humanity is not alone in the cosmos. It is simply uninvited to the deeper layers until it is ready. The final realization is that the universe humanity observes is only the beginning. Beneath the cosmic web lies another web woven by intelligence, one hidden by design, maintained across eons, and accessible only to those who reach a level of understanding that cannot be faked or forced. The visible universe is the surface, the hidden universe is the truth, and somewhere in that concealed domain, civilizations may already be watching us, waiting for the moment when we understand that the silence of the cosmos is not emptiness, but restraint. Thank you for watching. If you enjoyed this video, leave a like and share your thoughts in the comments. Send it to someone who you think would enjoy this topic too. And of course, subscribe and turn on the notification bell so you don't miss the next videos. See you next time.